Our last section of this unit turns to a different topic. We're going to talk about radical equations instead of rational functions. You've seen this before, so none of this should be real shocking information. We're going to solve equations that contain cube roots, square roots, any type of radical in them. If it's a problem with just one radical, they're relatively simple. You need to isolate the radical, square it, cube it, whatever it takes to get rid of the radical, and then continue to solve. So in this case, if I want to isolate this first radical, I need to get rid of the 5 first. You get rid of all things added or subtracted, and then get rid of any coefficients out front. So I add 5, that will give me 12. And then I'm going to divide 4 to get rid of the 4, and I'll have cube root of 2p plus 7 equals 3. Now I want to get rid of the cube root. How do I get rid of a cube root? Of course, I cube it. So I'm cubing both sides, and I'll have 2p plus 7 equals 27, which then makes it a relatively easy solve. 2p equals 20, and dividing by 2 will get me p equals 10. Okay. If it is an odd root, you do not have to worry about having to check your answers. If it was an even root, I'll explain why on the next problem, while it's necessary to check your answers. So on this next one, it's just a nice little square root, but there are issues when you're dealing with even roots. If I subtract 9, I'll get -2. Because whereas when you cube things, cubing, if something's positive, it stays positive. If a number's negative, it stays negative. But over here, where we are going to square both sides, I now have the risk of creating answers that don't work. Because in squaring it, as you'll see in this problem, when I square that -2, I've now made it become a positive 4. That may create solutions that do not check. So when I finish solving this, I'll have 6p equals 7, which means p equals 7/6. Since I don't know if that actually works, anytime you have taken both sides to an even power, you will have to check your answers. Actually, in the original problem. So I really have to put that 7/6 back in there for p. The 6 will cancel. Square root of 7 minus 3, so now I have square root of 4 plus 9 equals 7. Does 2 plus 9 equal 7? No, the squaring process messed up the positives and the negatives here. I would actually need -2 plus 9 to equal 7. So this one does not check. Consequently, 7/6 is not a reasonable answer, and I would actually say this one has no solution. So if you take it to an even power, you must check. Trying to find some place to write that. All right, so let's go have some pizzazz now. You may recall that these are the fun ones. We called these the ultimate problems back in Algebra 2 because they were the longest problems you learned to work in Algebra 2. Now they probably won't seem so elaborate here, but the key thing is you cannot, the temptation is great. Everybody wants to go square, 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 and get rid of it all at once. That is so illegal. Can't tell you how illegal it is. But I've showed you this many a time, and we'll show it to you one more. The reason you can't do that, we all know 1 plus 2 equals 3. But if you go square each one of them, 1 plus 4 does not equal 9. You cannot square individual terms. You can only square whole sides. Right now, I don't want to square this puppy. Don't write this down either if you're taking notes. If I square whole sides, I would have to FOIL that side together, and I would have to FOIL 2 square roots, which would be pretty horrible. So you don't want to do that either. That's a nightmare as well. Instead, you want to get your roots on opposite sides so that you don't have to FOIL them together. So you need to move one of them. Doesn't matter which one. In this case, I'm just going to move the second one. So I'm going to make it 7 minus square root of x minus 11. And now I am going to square both sides. I have the roots separated. I have one of them isolated. The key thing is isolate one of the roots. So now when I square both sides, the left side's no problem, but I'm going to write the right side out. When you square it, you are taking it times itself. Do not change any signs. You write it down identically. You are foiling this puppy. That is mission, 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 mission critical. You have to foil this thing. Okay, so left side's going to become 2x minus 5. Right side's got to be foiled. First, 7 times 7 is 49. Outers are negative 7 times the square root. Inners are negative 7 times the square root. And lasts are square root times itself, x minus 11. Okay, you'll notice we are now rid of one of the roots. We still have one of the roots. Okay, before you try to proceed to get rid of that root, you need to combine your like terms. Take one line of paper and clean this baby up. It will save a lot of frustration. So what can I combine here? 49 minus 11 would be 38. I would have, I'm going to put the x up front here too, and then I would have a minus 14 times the square root of x minus 11. Now, I'll admit I stole this problem from the college algebra book, and we're about to have some really whopping horrible numbers, but that's unfortunately the type of problems they dealt you. So we're going to have to contend with it. Okay, now the goal here is I need to get the root isolated again so I can square both sides a second time. In this case, since it's a negative 14, I really don't like that on the root. So I'm going to opt to move it to the right-hand side and make it positive. I think the root works better that way, which means then that I will have to subtract the 2x and add the 5 to the right-hand side. So that's going to give me 43 minus a single x. Okay, now here's where problems vary from time to time. You have the 14 in front of this. Sometimes that coefficient will divide over to the other side and divide evenly. If it will divide evenly into every single term, not just one, but into all the terms, divide it. In this case, 43 does not divide evenly, or 14 doesn't divide evenly in there. You do not want to make fractions. So we're going to leave it alone, and we're going to square both sides right here, which once again means I have another opportunity to FOIL this thing because it's two-term expression. Okay, one of the most common mistakes on the left-hand side first here, though, is when you square, you have to square the 14. So that's now 196 times x minus 11, not 14 times x minus 11. The other side we have to FOIL, and this is where it's somewhat ugly. 43 squared, 43 times 43 is 1849. Just realize we're taking 43 minus x times 43 minus x. Obviously then I'm going to get a negative 43x twice plus x squared. So the good news, we're rid of all the roots. The bad news, we have some whopping numbers to deal with. So now it's just algebra heaven. If we distribute the 196, we have 196 minus 2,156. On the other side, I'm combining like terms, and I'm going to put it in order from highest power to lowest power. So that's going to give me x squared minus 86x plus 1,849. Now I can proceed. It's quadratic. It's equal to, so we've got to get it equal to 0. And so it looks like I'm moving it all to the right-hand side. I'm subtracting 196x and adding 2,156. And boy, howdy, isn't this a pleasure? So I now have negative 282x plus 4,005. Whew, that's a problem. Haven't seen a quadratic like that. Okay. Now you have two choices. You can find factors of 4005, which in this case would have to add up to 282, or you could throw it in the quadratic formula. So most of you will probably throw it in the quadratic formula because, let's face it, finding factors of these kind of numbers is nothing short of horrendous. Now, I have cheated, so I actually know what the answers are, and I could find the factors. So, but I will be good like you'll have to do, and I'll set up a quadratic formula. 282 plus or minus 282 squared minus 4ac all over 2a. And the good news is you'll get two answers. Be sure you do both answers, both the plus and the minus. You will get 267 and 15. Isn't that great? Woo! Those are nice numbers. Okay, but are you done? And the answer would be, no, you're not done. You just squared both sides twice. You took both sides to an even power twice. Chances are excellent that one or both of these may fail to check. So you have to check them back in the original problem. So I'm going to go see if I can do a little check in this space here. The original problem, since I can't see it very well, I'm going to rewrite it, was square root of 2x minus 5 plus square root of x minus 11 equals 7. Okay, I'm going to check that. If I check 267, if I pop 267 in there, I find out that I get square root of 529 plus square root of 256 is supposed to equal 7. That will give me 23 plus 16 equals 7. Does that check? No, it does not. So therefore, 267 is not a solution. It's what we would call an extraneous solution, because it was a solution that did not check. So now I would have to go back and try to check x equals 15. That's a little nicer. If I check that and I sub 15 in there, I will have square root of 25 plus square root of 4 equals 7, and which would mean 5 plus 2 equals 7. I believe that does check, and so 15 is our one and only solution. Boy, wasn't that good fun. Some awesome, awesome numbers there. But, hey, you have technology. You can handle it. Last kind of problem you're going to have to deal with is equations that have rational exponents, meaning exponents that are fractions. Okay, we've dealt with these before. I'm going to actually, you'll notice I have the same problem twice here. I'm going to show you two ways to work this, and it's pretty much your choice which way you prefer. Okay, because they're rational exponents, they're the same thing as radicals. We know fraction exponents become roots, so it's essentially like working a radical problem. Okay, one option is if you don't like the rational exponent, you can turn it into a root. You can actually make that x to the 5th in a square root. I'm going to subtract the 7, which would make me have a 32. And then go ahead and solve it. How would I solve? I would have to get rid of the square root, so I would be squaring it. That's then going to give me x to the 5th equals 32 squared, and unfortunately I don't know 32 squared, and I'm running to a calculator to find out 32 squared. And the answer is 1024. Duh, I should have known that. 2 to the 10th power is 1024. Okay. And then we have to 5th root it. So when I 5th root it, I get x equals 4. Okay, that's not horrible. You did, however, square both sides, so you would have to check this answer. You would actually have to do what's 4 to the 5 halves plus 7 equals 39. Okay, well, 4 to the 5 halves, that's square root of 4, 2 to the 5th power is 32. That's 32 plus 7 equals 39. Yep, that checks. Okay, I personally think that's the slow way. That's the way that you're probably most comfortable with, but that's the slow way. Let me show you the fast way. The other option is to leave it as an exponent. Subtract the 7 and get the 32. If you want to get rid of a 5/2, you simply need to take it to the 2/5 power. Do the reciprocal power, because when you multiply the powers, it's going to cancel. Now, of course, then I have to take 32 to the 2/5 power. So then I'm going to have to work out what's 32 to the 2/5 power. Well, we just did it. 5th root of 32 is 2. Sorry, that's supposed to have a square on it. So then I do 2 squared, which is 4. Now, how do you know if you need to check these? On the other side, you can clearly see you squared both sides. Well, we did square both sides. When there's an even number on the top of that fraction, if that's an even value, even number on top, you got to check. Because if that was x squared, then it was like you squared both sides. So we would have to check again, and it would be checking exactly the same as the check I did on the previous problem. So it's up to you which way you prefer to work it. Now, some of them, you'll notice this just had one x to a fraction power in it. Some of them will have more than one x. But they're going to be in what we call quadratic form. They follow the pattern of a quadratic equation. You're going to want to set these equal to 0. And let me do that so you can see the pattern here. Minus 28. Okay, notice you have 2/5, you have 1/5, and a constant. When we do a quadratic equations, you have x squared, you have x to the first power, and you have a constant. If you were going to solve a quadratic like this one with fairly easy numbers, you'd go factor it. You'd factor it with x and x. Notice we would be factoring with whatever the power on the middle term is. Well, in our case, instead, I'm going to factor with the power on the middle term, which is x to the 1/5. And once you see this happen, it will make sense. If I factor with x to the 1/5 and x to the 1/5, when I multiply those, I'll add the exponents. 1/5 plus 1/5 will make the 2/5 I need. So if you always factor with the power on the middle term, it'll work. Okay, I still need factors of 28 that'll make a 3. Well, that's got to be 7 and 4. I need a positive 3, so it's got to be a plus 7 and a minus 4. Okay, then you're going to proceed to set each of your factors equal to 0. So if I have x to the 1/5 plus 7 equals 0, I have x to the 1/5 minus 4 equals 0. I'm going to subtract 7 over. You could put this in a root, but once again, I'm going to tell you, I think it's faster. If you want to get rid of a 1/5, what power do you have to take it to? The 5th, the reciprocal, because they'll cancel. So then I would have to take both sides to the 5th power. Okay, negative 7 to the 5th is a somewhat large number. It comes out negative 16,807. Nice number. Okay, doing the same thing over here on the right side, I would add the 4 over, and I would take both sides to the 5th power. And so I would then have 4 to the 5th in this case, which is 1,024. And I'm getting really close to the edge there. All right. So I have two solutions. Do I have to check my answers? Well, did I ever take both sides to an even power? In this case, I took both sides to the 5th power. That's odd. So I didn't accidentally change any positives and negatives. So these would both be good answers. You would not be required to check this. If I had done both sides to the 4th power, I would have to check my answers. But since I did the 5th power, it's all good. Okay. Hopefully you'll find this assignment a breeze compared to the last one. Get radical and enjoy those equations.